So in question 18, we're asked to show that these two cartons are not mathematically similar. Keyword not. So the way I think about this is I'm like, well, what would happen if they were mathematically similar? Well, we would find the linear scale factor. So we'd find the linear scale factor and then find the volume scale factor. So, and then multiply the volume scale factor by this, and we should get this. So let me just say, if it were, let me just reiterate, we would just do our normal thing. We would do our linear scale factor, cube it, so we would get the volume scale factor, and then multiply our value here by that scale factor to get the value of the large. However, we're told that they're not mathematically similar. But that doesn't mean we change the process. It just means that this, or I should say that our answer to this multiplied by the volume scale factor is not going to equal that. So we just need to show our working for this, which is why it says prove. So step 1, we're going to find our linear scale factor. So I'm scaling up here, so I'm going to put the largest value on top. And I know dividing by 8, that's 3 over 2. Then we're going to do 2 volume scale factor, which is 3 over 2 cubed, because we're doing volumes. So 3 cubed is 27, 2 cubed is 8. Now, third step, I'm going to take the volume of this small one here and multiply it by this 27 over 8. So 576 times 27 over 8 is equal to 1944 centimeters cubed. Now, you see here that 1944 does not equal 1125. Hence, they are not mathematically similar. So this is going to show you that actually we've done the right thing. So then we write a conclusion. The cartons are not mathematically similar since since 1944 does not equal 1125. And that'd be your answer. So just to go over that again, we find the linear scale factor, just the normal process. Make sure you do the large one over the small one if you're using this, because you're going from small to large, and then that's you. Thanks for watching. So fortunately I think part B is slightly easier. So what you do in part B is we need to calculate the depth of the redesigned large carton, and we're told that the volume of the redesigned large carton is changed and we're asked to find the depth. So what we need to do is find a scale factor again, but we don't have the information to find the linear one because we don't have the depth. That's what we're looking for, but we do have the information to find the volume one. And since we're we're looking to find something about the large one, we'll be scaling up. So that's our volume scale factor. Now if you remember that volume scale factor is actually linear scale factor cubed. So to get linear scale factor from volume scale factor, we take the cube root of it, like this. And then, I'm just going to write this out all in one step because I have up on my calculator. So that would be this bit here in blue represents our linear scale factor. So how do we find the depth of the redesigned carton? Well, we take our linear scale factor and then multiply it by the depth of the small carton to find the large one. So doing this gives me 22.0128483. So I'm going to round that to 22 centimeters. So there's a lot of ways to do this, but that's just to reiterate what I did there. I was like, okay, well we can't find the linear scale factor, but we can find the volume. Found the volume scale factor, which was this. Knew I was scaling up, so I put the bigger one on the top. I was then like, how do we get the linear one? Well, we take the cube root of it, because we cube the linear scale factor to get the volume scale factor. And then, how do I find the depth? Because this is what they're asking for here. Depth. Well, we just take the depth of the smaller one, then multiply it like that. So, give yourself a tick. Thanks for watching, everyone. This was a hard one, so...